Welcome everyone to the latest and newest Integration Quest MuleSoft study group. Glad to have you all here today. We have a full house, a lot of people here today, and so glad to have you all. And today we have Ryan presenting. He's going to be presenting on the anatomy of a mule flow. So glad to have you here today, Ryan. Thank you so much for coming out. I've got a couple of things to go through like I always do, and then we'll just turn it over to you, okay?
Sure.
Everything's been going great with this little code of conduct here. Everyone's been doing great, and we really appreciate it. So we're just going to go on and we're going to keep on having that great success on everybody doing what they're supposed to be doing. The next thing I wanted to show you, and I'm going to actually just drop this in the chat since we have so many people here today. This is the Integration Quest YouTube channel. Like it's a library, okay? There's just a lot of knowledge out there. It's a wealth of knowledge. You can come out there. You'll catch this very video out there. You can come out and just learn and check it out. I've heard a lot of feedback recently, even of people saying, wow, they're just amazed of all the information that's out there and all of the archived videos where they can go out and they can learn just like we're doing live. You can do it if you miss something and check it out later at your own leisure. So while you're there, please subscribe, drop a comment. I love seeing comments. We've got a new subscriber today, but I didn't get any new comments this week. That's okay. Leave a comment. Let us know what you all think about it. And I'll reply back to you. I love talking to people on there. So go check it out. Like I said, today we have Ryan with us here today. He's got a lot of experience, been doing this for a while. And like I always say, it's not just about the experience. It's the fact that he's willing to come in here and share that knowledge and share and learn and grow with us. You know, like our presenters always say, they're not just presenting, we're learning together. We're just doing this together. So since we're all doing this together, like I always say, I'm going to go ahead and I'm going to turn this over to Ryan so he can do this presentation. I'm going to keep an eye on the chat. So since we have so many people here today, Ryan may not be able to keep up with the chat. I don't know. He's usually really good at it. By the time I try to jump in and say, hey, Ryan, you got a question? He's on it, but you may miss it today. So I'm going to keep an eye on the chat just because I like to. Y'all drop some questions in there and we'll answer questions as we go because it's a study group. We don't want this to just be, only like Ryan talking. He wants to get some feedback. I know if I'm presenting, I want feedback. So I know everybody's awake and paying attention. So y'all jump in if you have questions as we go. Okay. It's all you, Ryan. Thank you so much for being here today and carry on.
All right, thanks. I sent you a note in Slack, RJ, if you want to check
that. Yeah, I'll take care of that.
Yeah.
Gotcha, buddy.
Hi, everybody. Oh, man. This thing called Mule, the anatomy of a flow. This is an excerpt from a class that I teach on MuleSoft architecture for Integration Quest. One of my students from the very last class is here. Hello, Sun Young. So you saw a version of this lesson in class last week, but I figure it's good. It's an essential part of why we use Mule to write integrations. So what is this Mule thing? Mule used to be a long time ago a Java framework that was that it's not anymore. It's not a Java framework anymore. Ross Mason made this Java framework in the early 2000s for making Java integration programs easier to write through connectors and transports and endpoints, enterprise integration patterns. He was implementing them in Java and making a little XML language for kind of stitching them together. And what has happened over the years is it matured into a full-fledged high-level programming language where the unit of programming is a flow, right? So I thought I'd make a little lesson about what exactly are flows. And I'd like to start not so much with the flow. I'm going to start with our little friend, the Mule event, right? So think about most computer programs you've ever when you write code in a programming language, a procedural language like C or Python or JavaScript. Your code looks a lot different than Mule code, right? Maybe you have functions. Not all programming languages have functions, but we call them C-like programming languages if they have a function. And your function is the unit of code that you're telling the computer what to do, right? You make this little block of text, right? And you give it a name, and maybe you give it some parameters, and you give it a return value. And then in between, you put the lines of code. and that's how it turns input into output, right? So your little unit of code in your program is a function. It turns some inputs into some outputs, and then you can kind of assemble that into a larger program. So at the next level up, Mule is a different way for you to tell the computer what to do. Using a unit of data called a Mule event. A Mule event is a strict kind of data. Well, it always has the same data model, doesn't it? So, in like a C function, you can make your function take an integer or a string or a structure that you make that's got 2 integers and 3 strings or whatever. You can build your parameter type and you can build your return type, and then any function can have any input and output, but a Mule flow doesn't. A Mule flow is an implementation of event-driven architecture called staged event-driven architecture. So it's a way the Mule program is written where the units of code that you write, I call them processes, but you could call them code, right? Your code, the input has to be an event and the output has to be an event. And that's what every flow is. It starts with an event and at the end is an event, right? You can't give it a return type. You can't give it a parameter list. You just always get an event in and an event out. Now, the event can contain a payload that could be a string, or it could be a structure or a JSON or whatever. And that's where data weave is helpful, right? Is you can interpret your payload however you want in your code that you wrote, right? So the first part, the first thing Ross was trying to do with Mule is make an event-driven programming platform. And why? Well, because Mule isn't just for all kinds of programming. Mule is for a very specific kind of programming. Mule is an integration language. It's only for integration. It's not going to be used to make a calculator or a web browser or a video game. We wouldn't do those things in Mule. Why? So MuleSoft made this language, Mule, to help us be better at doing integration code. And integration code is always back-end code, right? It's always in the middle of other code. I have my own little visualization of this. Looks like this. We're building these things, these little programs that sit in between other programs and pass data back and forth. So it's nice to have a special purpose programming language just for writing these kind of programs. So event-driven programming makes sense because every one of these programs, it doesn't have a screen. It's not an app on your phone. It's just running, waiting for input to come in so it can send it on its way to the next step. That's really the constraints of what the Mule programming language is designed for, right? So we have these little event-driven programs, and what we learned in Mule 2 and in Mule 3 is that this is too free. It's too loosey-goosey. If you build event-driven integrations, which we were doing this in the 2000s, if you build event-driven integrations where any code can wake up anytime there's any event and it can output any events, you end up not having very well-designed integrations, right? So MuleSoft is a language for a special kind of event-driven architecture called staged event-driven architecture. Let me go back here. There we go. And all that means is it's an implementation of the pipes and filters pattern where the events that come out of one process are designed to be the same events that are the input for the next process. So you chain them together, right? So that's a staged event-driven architecture. So, my code and your code that's going to call APIs or query databases or write files or something, right? Make connections to RabbitMQ servers, like whatever that code is going to be lined up in a chain, like where you have each of your steps and you chain the output of one step to be the input of the next step, right? That's what your flows really are. Now, these processes are flows, but a flow is a very special kind of process that can route events to other event processors, right? So here's a flow, and I want you to think at runtime. This is a Mule flow when the application is running. So a Mule application launches, and it doesn't just launch, right? There's layers to it. There's a Java runtime, and the Java runtime starts. It's a process on your computer, right? And then on top of the Java runtime, the Mule runtime starts up. So you can, when you run Mule, you can see that, right? Java starts, and it starts pretty quickly, right? And then all the Mule internals start on top of the Java runtime, and you'll see the scheduler execution service start and the court scheduler and all these little components of the Mule runtime that support your flows have to start first. So there's a life cycle, meaning that there's a startup period where all the Mule stuff has to start before your application starts. And where are the flows, right? The flows are inside your application. So the flows are not there yet, right? Java starts, Mule starts, and then after Mule is starting, it finds your application, and your application XML code, which is going to look like, where did I minimize it? I put it on my other screen. Let me find it. I guess I'll do it this way. I don't know where I put it. Show all windows. There we go. There's my XML code. Right behind me, right? It doesn't look like XML when we edit it, right? The purpose of the Mule graphical programming language isn't to dumb it down. It's not here because programmers are stupid, right? It's here because it's the best way to think about what your integration does. Each of these steps in your flow is an event processor, right? So my job as a Mule programmer is not to think about, all these layers of Java and Mule and the jar file. And no, that's all done for me. And I'm controlling what the processes are that are chained together by these Mule events, which are actual real data in RAM, right? So the events are produced by event sources, right? So an event source is one of the first things that starts. When you launch your Mule application, your flows are going to start, your event sources are going to start, and then your event sources can, whenever at a later time, they can produce these things called Mule events. And that's all they do, right? In my flow here, I have a scheduler event source, right? Or I can have another flow with I guess this is a VM event source, right? Or I can have another flow with an HTTP listener event source. So the connectors provide different ways that Mule events can be brought into being. And I'm not being philosophical and abstract. Brought into being really does mean, right, that a Java object is going to be instantiated on the Java heap. And that's what the Mule event is, right? And that's all the event sources do, is they make these Mule events, and now they exist in the Java heap when the application's running. And they contain whatever data the connector pulls off the disk or takes off the socket from an HTTP request or pulls out of a VM queue if it's in RAM. So there's different ways the Mule event's contents might be populated when the event source produces it, right? But that's the key. That's all this event source thing is doing, is it's just manufacturing these new Java objects called Mule events. And we have these things called flows that can subscribe to the event sources. So your flow, which is where your code lives, is subscribed to an event source. And all that means is it's going to get a copy of the Mule event. It's going to get this Java object in RAM. And now it can route that to a series of event processors. So this is the mental model at runtime of your Mule application. This first event processor might be an HTTP request, right? And this one might be, I don't know, a transform message, right? Those event processors really do exist before the data needs to be processed. Before any Mule events exist, all of these components already exist at runtime. And they're instantiated and they're started, and now they're waiting for work to do, right? So this HTTP request, it's sitting there when the application is launched doing nothing, right? Just waiting for some work. And then every time the flow publishes an event to it, that's the input, right? The Mule event is the input to the HTTP request. It can go off and do its job. And when it's done, it makes a Mule event. Every event processor in Mule, its job is to respond to Mule events, do some work, make some more Mule events. Everything. And it's constrained to exactly one Mule event in, one Mule event out, so that you can have a clean mental model of what your application is doing when you program it with these nice little graphics, right? Now, there's these special ones like the round robin that do extra Mule event stuff on the inside, right? And those are called routers. So the basic flow here, there's no routing, right? Every single step of the flow exists at runtime. It subscribes to events from the scheduler event source, and then whenever one is received, it publishes it to the HTTP request event processor. And that little step, that's all the flow has to do, is pass the event to the request. And now the flow's work is done. So it's really nice because the Java runtime is running on a machine that has a CPU, and the CPU is busy whenever you give it a thread to execute, right? So that step of passing the Mule event from the scheduler to the request is a very quick and easy step. And then you don't need a thread anymore. So the flow doesn't hang on to a thread. This is a big innovation that happened between Mule 3 and Mule 4, is that the flow doesn't hang on to the Mule event with a single thread all the way to the end, unless there's a very special case. That's an exception. My students in here probably already remember. Who knows what the exception is when it does hold on to a thread all the way to the end? Anybody put it in the chat? There's an exception to that. That's a trivia question. Here, I'll do it real quick. We're going to surround this in a triscope. And then the triscope is going to get a transaction. And now, oops, now we have to have a thread for the whole transaction. That's the exception to the threading in Mule 4. Is in the scope of a transaction, the Mule event has to stay with the same thread to the end of the transaction so that it can roll back, right? But outside of that one exception, Mule doesn't need to hold on to threads for very long periods of time. Amrit got it? Oh my gosh, I missed it. I must not have been looking at the chat. Good job, Amrit. 10 points for Amrit. I don't usually give out 10 points. You guys know that, right? Who's been in my class? I usually give out like 1 or 2 points. So I missed it, Amrit, so you got bonus. Yeah, so there's just a thread needed to carry the event from the source to the first processor. And then maybe that processor needs its own threads, right, to do its job, but that's not the flow's business, right? And then whenever the processor emits an event, the flow is subscribed, right? So that's this next stage here, right? The flow is the one that's watching every one of these event processors to see when it emits another Mule event, and then it can pass it on to the next step. Serge has a chat. What will happen if the requester endpoint is down while publishing the event to it? That's error handling. So good question. Okay, so nothing interrupts what I'm showing you here. Even if an error happens with the request, it's an integration platform, and errors happen all the time. All an error is just another kind of Mule event. So pick up on that, right? If the HTTP request succeeds, it's going to emit a Mule event. If the HTTP request fails, it's going to emit a Mule event anyway. It always emits a Mule event, and it always emits exactly one, right? So when that Mule event comes out, it will, if the request failed, it'll just have an error included with it, right? And an error is just like a little data structure, right? It just has some information in it about what went wrong. Maybe 404 not found, maybe connection refused, right? It's a lot of different errors that could happen. So you need to put those in a little data structure and stick them in the event, and then the event comes out.
Another really good question in the chat. Do you see that?
Yeah, Sang Young says, why does MuleSoft use PubSub in flows? Is it for asynchronous event-driven communication between decoupled systems? Well, I want to be careful with vocabulary just about PubSub. I think I get the point of your question. Why is it using event-driven architecture at all? And I'm going to answer that second. But first, Mule does not use PubSub. There's point-to-point and there's PubSub channels, right? So PubSub is when you have many subscribers. Mule only has one subscriber, and it's the flow for every single event processor. So you'd call that more of a point-to-point channel, right? Now, there's no queues in Mule. It's just in-memory events. The implementation of this is called reactive streams in Mule. It looks like this. It's now part of Java. I have a better, here's one of these. Reactive streams is more flexible than Mule, but it's a way of chaining together asynchronous lambdas. So when you write this in Java, it's way uglier. When you write reactive code in Java, it's subscriptions, and it's notifies, and it has to have errors handled differently than successes. So MuleSoft took reactive programming, which is rather complex, and they simplified the way that I specify what I want so that it looks like graphics, right? And the reason MuleSoft used, I'm still back on Sung Young's question, the reason MuleSoft used asynchronous communication for this is that we do not want to tie up the very precious CPU when there's nothing to do, right? This program, these Mule programs are, right, they're on the network. These Mule programs mostly don't care about CPU, right? Mostly our job is passing input to output and then waiting around for ages for the network to pass packets around, right? Or maybe we're waiting for this hard drive to put stuff to write. The CPU is far faster than the network. So if we're going to optimize an integration program, we want the integration program to be extremely conservative about when it ties up the processor, right? So Mule used an implementation of asynchronous programming called reactive streams and wrapped it up in an XML language that we can edit with, graphical diagrams. And now all of us are reactive programmers who don't tie up the processor waiting around for a network request to come back, right? That HTTP request, I love this demo. We're all a little annoyed with Postman as a company, right? But if I send a request here here's one. I can send this request to MuleSoft.com. Look at this. It took me 227 milliseconds. That's a fourth of a second, right, to send that request to MuleSoft. And I'll do some very quick mental math for you. But my processor is a Apple M3. I have 4.0 gigahertz cycle time on my processor. So that's almost a billion cycles on my processor waiting around for a web request to come back. So if I have a thread open that entire time, I'm tying up 1 billion, 9 zeros, right, cycles on my processor, waiting for the network, right? So it's very important not to use threads while you're waiting around for this network request to finish, right? And Mule doesn't. That's the nice, all you do is you make these little flows, and Mule just doesn't have a thread when the request is waiting. I have a few backed up questions. Sush had a follow up on the error handling. Okay, so with error handling, there won't be any message loss. Is that correct? Yeah, there's not a way that your Mule flow ever, unless you terminate the program early. I guess that's the way, right? But here I'll do the CETA diagram. Every single Mule event that goes in to a process is guaranteed to have one Mule event come out of a process. Whether it's an error or not is yet to be determined, right? So, but you're not going to have 0 come out, and you're not going to have 2 come out. One event in equals one event out, not because of any systems constraint. This is the way MuleSoft designed it on purpose so that you and I can think about the program. In Mule 3, that was not the case. It was great. I think Mark, I know Mark Knox. I've known him for a long time. In Mule 3, we had this one called Splitter. It was an event processor called Splitter. What did that one do? You remember, Mark? I don't know if you remember what that one does. It's been a long time since Mule 3. He's not off of mute. I'm just going to draw it myself. So Splitter this is not in Mule 4. This is not in the current version of Mule. In Mule 3, you could give it an event, and maybe that event was a database select query result set, right, with 108 rows, right? So this event contains many items in the event, right? So in Mule 3, MuleSoft thought it was a good idea to let us have a splitter which output 108 events, one per row, so that we could then just process them on the next step. Maybe we're going to transform them or send them to an API, which, if you're an academic computer science guy, maybe you think that's a great idea. When you and I go to write programs with a splitter, it looked like this. It looked like in a line. So whatever the third step was would happen 108 times. And turns out that's kind of hard for me to reason about when I'm looking at the code. It's perfectly valid way to make the program work, and very unmaintainable for integration developers. So in Mule 4, they got rid of that. In Mule 4, if I have a select statement, here, I'll make one. Now I make a little database select statement, right? And it's still going to give me a Mule event, like select whatever from table, right? And this is going to be gives 108 rows, right? Now I'm only going to get one Mule event out that contains 108 rows, just like before. And if I want to loop over them, I have an event processor called for each. And inside the for each, you're going to get 108 items. You're going to get 108 Mule events only inside the for each. So this, this will happen. This will be executed 108 times, right? And this produces one Mule event containing a payload with 108 items, right? And then inside the for each, you're going to get one item at a time. And then you get to the end, and guess how many we have? Back to one, right? Here, this will execute exactly one time. We're back to that. We're always going to get one event into the for each, one event out of the for each, even if a bunch of stuff happens inside the for each. That MuleSoft made a promise to us that it's always one event in, one event out, but still left the programming power there for you and me to be able to loop over things. And not only just to loop over things one at a time, they gave us two different options, right? There's another one where we can do them all in parallel. So same idea, but instead of one at a time, now it just does a whole bunch of them at a time, right? This is still going to be executed 108 times, just we're not going to wait around for the first one to finish before the second one starts. You know, they're all going to run together. And then we still get exactly one thing after we're done, right? So yeah, that's the, I think that was my long answer for that one. Greg says, is it true that they just decided they didn't have to do the entire EIP book with all those patterns? Oh, Greg, Camel tried to do that. Apache made this open source implementation of the enterprise integration patterns called Camel, which is excellent. I love the product. I still think Mule is better because they didn't just take the book and make it into XML, right? The book was good inspiration, but what that MuleSoft made for us instead is a programming language, a graphical. Well, it's not just graphical; it's graphical and XML, right? Those are isomorphic. A graphical way to write event-driven programs that execute Mule events asynchronously. Is there any size limit on a SQL result set for one Mule event? Here, let me get rid of all this stuff. These are my old diagrams I use. No, there's not a size limit. That's a different. So let me answer that question a little more deeply than that. The Mule event has a payload, right? This payload can be any Java type, right? This can be any Java type, right? And you know, when you do a database query, the type you get is a it's this managed stream cursor iterator, which you never have to look at, right? Because Mule just handles it for you. but what that means is it is a stream type, not a in-memory type, which means I haven't actually downloaded all those rows from the database yet, right? I have the ability to later in my program. If I need to read them, then they will get downloaded. So what the Mule event has in it when it comes out of this select statement is a payload that contains a stream object. And when the parallel for each tries to read stuff from the stream, then it gets downloaded and processed. But that gives you the opportunity, if you go back to like the for each, where you could just do one at a time and not have to hold all of them in memory, right? So I mean, if you're not doing it that way, if you do something to make the whole stream have to be in RAM, then my other answer for you is yes, there's a size limit, and it's how much RAM do you have in your Mule program, which usually isn't very much RAM. Usually you're running, these little Mule applications are extremely tiny. So that'll be another quiz question. Anybody, if you run the normal Mule Cloud Hub app, how much CPU and RAM and disk does MuleSoft, what's like the normal amount of resources you get to run a Mule app. Anybody want to guess that one? CPU, RAM, and disk. Give me all of it. The CPU is going to be in units of cores. The RAM is going to be in megabytes or gigabytes. And then the disk is going to be in gigabytes. 512 meg, 0.1 vCore. Yeah, 0.1, not 0.01. No, not 0.01. That would be really small. That'd be 100th, right? Yeah. So you get a tenth of a vCore, right? You get a tenth of a virtual core. You get half a gigabyte of memory, and you get 8 gigabytes of disk. And that's all you need for most everything you do in integration, because of streaming and because of the processor limit. Because remember, these are not computing applications. They're not doing algorithms that much. Maybe transformations and stuff in data weave, but I mean, like, that's it, right? They're not for computation, right? They're for integration, right? And so it's a special language for integration. So this was really the main lesson I planned for today. I wanted to get into this and give people a chance to ask questions about it. I don't have more planned. So we can just take it and do a study group out of it. So what do you guys want to talk about the Mule event and about flows and CETA and threads and what Mule's doing with this flow programming language? Jonathan, should the sub arrow, what I was trying to indicate with the arrow directions, this is a graphic design thing more than anything else. Thank you, Jonathan. Yeah, so Jonathan asked, on the flow anatomy tab, should the sub arrow point the other way? If you're talking data flow, probably. I was trying to communicate control. I wanted to get across the idea that the request doesn't know about the flow, right? The flow knows about the request, but the request doesn't. It just gets events and emits events, and that's all, right? So that was my reason. Maybe it was more of a control or a dependence. Maybe it's dependency arrows, I guess. So that was maybe how I thought about it. But I could see the argument for reversing this if we were talking data flow, right? Here, I'll do it. Let's see what it looks like. I don't mind. Yeah, data flow would go like that, right? So I don't know. Good comment. Let me see. What rationale remains for the use of a subflow? Okay. There is a difference. Is it actually subscribing? Now, Jonathan. So Vincent, I'm going to hold yours. Jonathan is on a path. Jonathan's going in a good direction here too. It's not actually, it is actually subscribing. Honestly, the request is technically subscribed to the flow also. I'll show you some code, Jonathan. There is real Java I can show you. If you write connectors in the Mule SDK, you end up working with this kind of code. So every event, this function you're looking at, this is an event processor, really. So everybody complains about Mule's XML code. I just want you to sit back and appreciate that you don't have to write this. This is worse, right? I enjoyed writing it, but it's not what most of us want to do when we're writing integrations. So this event processor function accepts a set of parameters, and these are all provided at the time the application starts up, right? And then you have to subscribe to the you have to return a callback object, and the callback object is going to be subscribed to the last step, and they all go in a chain, right? So what this function does is I'm passing it into, in this particular library, I'm passing it into another reactive framework. So this might actually be a little harder to understand than if I open. Let me do another connector here. What about, like, let's do, I think I just did that one. And I'll do my operation. Yeah, so this is the same kind of thing. So you pass, you have to do these when complete operations. You see what I have here is a lambda. If I put a space, like make it obvious, this thing up to here is a lambda. I'm defining a lambda function, an asynchronous function in my connector, and that function will be executed after a asynchronous operation happens, right? So we have to chain together these functions to be executed later. And then when they're done and when they execute, they have to, their job is to call my callback rather than to, like, either with a success or an error, see? Rather than to do it immediately, right? So this whole function gets subscribed to the step before, and the flow is the one that's in the middle, right? So the flow is going to call this function, or it's going to pass an event into this function every time an event happens. And that's what's happening right there at the publish step, right? So my request doesn't, you see what I mean? It certainly has no reference to the flow object here. There's no there's no knowledge of the flow. The flow knows about this, but this doesn't know about the flow. It's the other way around, right? So it's going to get the event passed into it, and then all it does is call a callback with the result. And then the flow is the one doing something with that and passing it on to the next one. I hope that wasn't too much Java. Vincent says, what rationale remains for the use of a subflow? Yeah, that's much more on the first level deep of this, right? So I have a picture of that. The subflow does not exist when the application is running. It's a big difference from a flow. A flow does exist. A subflow isn't. A subflow is inlined by the interpreter. So let me show a picture of that one. The magic of a subflow is all in the flow reference. So there's an event processor called flow reference, and it can become the event source for another flow, right? So if I make this flow reference point to flow 2, which is not a subflow, right? There's flow 2. Now, when the application runs and an event arrives at flow 2, there's a dynamic event source for actually flow 2 that produces a Mule event, right? Of whatever Mule event arrived at the flow reference. So that the flow reference at runtime will act as an event source for flow 2. Flow 2 actually exists at runtime, gets events, routes them like normal, right? That's what a flow reference does for flows, right? What a flow reference does for subflows is way different, right? So let me do the email subflow 2. There we go. Now, if I change my flow reference to a subflow 2, when the application is getting deployed, the flow reference disappears. And the contents of subflow 2 are just stuck into flow 1. The subflow is like a macro. It doesn't exist at all at runtime. Big difference. So flows exist at runtime. And you can kind of tell here in the editor, right? Because like subflows, look, there's like no programming. There's no way to configure anything about a subflow. But on a flow, you have you can make a flow be stopped or started, right? You can give it a max concurrency for back pressure. You can have events tracking. Subflows have runtime behavior, right, attached to them. Subflows don't. Subflows are just macros. They just zap the stuff from the inside right to the flow reference location. So good question on that one. Difference in resources is not really that different, Vincent. It's a little bit. I mean, I guess the flow consumes a little bit of RAM when it's running. Has to take a little while to start up when the application is getting started. But the main thing is that it can hold real, like it can do things. You can make it stop, right? I can have a stopped flow. I can't have a stopped subflow. There's no such thing, right? I can have a max concurrency 2 on a flow, but I can't do that on a subflow. Yeah. Sung Young says, are there guidelines for beginner Mule developers on when to use a flow, private flow, or subflow? Yeah, I would say just if you're not sure, always use a subflow, because then, like, if you ever do need something that a real flow can do, then you'll have to change, right? You'll switch it over to a flow. Subflows are, I can't think of any disadvantage except for making trickier M units. Subflows are a little bit trickier on M units, and that's okay, right? I would say basic guidance I would give for Mule developers is just use subflows unless you have a good reason not to. And you'll know if you have a good reason not to. Yeah. Subflows don't have error handling. Vincent has a good point, right? Because how could they? They don't exist. right? They're not there. So they can't handle errors, right? But you can always put a try inside a subflow, right? And now you have your own error handling. That's perfectly okay pattern, So it's error handling to me is not a sufficient reason to upgrade to a flow. Maybe it's, and I wouldn't fail your pull request. If you sent me a pull request and you had a flow and all it did was have an error handler, I would approve that. It's not that big a deal, right? It just seems to me simpler to just have subflows with error handling in a triscope. So the rest of your question, Sung Young, if you go use API Kit, API Kit is going to make a bunch of private flows that have to be private flows, right? All of these API Kit router flows. So when you use RAML and you generate, you scaffold the application from your Anypoint platform, every one of these is a special real private flow, and it has to be. You can't turn those into subflows and have the application still work. So that's one time that you definitely have to use a private flow instead of a subflow. Is API Kit. Good. What else? Is there a reason to create a custom connector for Redis? Do you want to go down that rabbit hole, Sonny? I did it. I spent probably a full month worth of hours writing that thing. I could tell you why I made the custom connector for Redis. It's not about flow anatomy. It's a little bit about flow anatomy. Okay, so Sung Young called me out. I made a custom connector for Redis on MuleSoft Forge, and MuleSoft already had one. So why did I do that? Let's show you why I did that. So first of all, how many operations do you see in here? There's like a couple dozen operations in the, this is the MuleSoft Redis connector. And if you go to redis.com, redis.io/docs, let's see how many commands Redis has. Here's all the commands for Redis. Look how many there are. I mean, more than a couple dozen, right? So my first reason I needed a connector is I couldn't do all the commands with the one that MuleSoft made, right? And the other thing I want you to notice that the MuleSoft connector, they renamed all the commands to their own English words, which I thought were not very close to what Redis is. So my connector actually has the Redis commands as the names. The main reason actually I made the connector is a little more practical than just that. Some of these commands are extensions. So you can install an extension in your Redis server and get these kind of commands that don't really belong in the connector, right? Because they're part of an extension. And so if you want to support those or Lua commands, I made the connector have, here, I'll just show you on MuleSoft Forge. I made the connector have a just a send command one, right? So it's this one, you just give it text and it'll send anything you want and get the results back. So that was the first time I needed it, Max says, is it worth doing a custom connector for something with a well-described API? Yes, I think it is definitely worth doing a custom connector for something with a well-described API. So there's it's always better to have a connector. It's not always worth the time and effort to write one, Max, but they're always better to program with. How about, because every API has its own little stuff to it. So I've been doing QuickBooks Online for a project of mine. They have a pretty normal API. There's nothing, I can't complain, right? It's a pretty good API, right? They've got a lot of these functions in here. Look at all these functions in here. And I don't need all these functions, and neither do you, right? And there's actually two APIs. There's an accounting and a payments API. So when you use the HTTP connector to just use this, it makes the code extremely particular to a version of the API and to whether you pick JSON or XML. And you see what I mean? All this, there's a lot of complexity to understanding how to use it. So the same maybe value that an SDK brings to any programming language, a Mule connector, it's like a Mule SDK for QuickBooks Online, right? And it would make sense to have things like, so for example, with Redis, there's a command to subscribe to a channel, right? And that means now Redis is going to push stuff to me. And so with a connector, I didn't have to do some kind of HTTP thing. I was able to make I don't have my connector in here. I was able to make a source, right, for the subscribe operation. And now it just gives me a Mule event every time something comes out. And it internally does the subscription for me. Same thing with paging. A bunch of these operations, when you do like a query in Redis, it'll give you back up to a certain amount. Like it'll make up when it pages. It doesn't let me. I mean, I can give it hints, but it might give me a result set with a cursor and say call again to get more results. So my connectors do that internally, right? So instead of having to do the part where I detect whether or not there's another page and then make a call to get the next page, my connector just has that inside it. And when I write code with Redis, the connector, I don't have to deal with paging, right? So the connector gives you a client experience that's better than just using raw APIs. And to your question, it's not always worth all the effort to go write one. Although I will say coding agents have changed that calculus. It is now less trouble to write good connectors than it used to be, right? Because Claude Code helps me a lot with this connector. So yeah, good points. Thanks, Max. Maintenance point. Yeah, because you have to maintain the connector. So that's that's my argument about MuleSoft Forge is let's amortize that. Let's share the maintenance cost between all of us in the community instead of have just your company have to do it, right? And I haven't had a whole lot of people do it yet. I have got 0 pull requests so far for my connector, but hey, it's possible. Hey, that's the dream of open source, right? Sung Young do you think a connector is better than a standard REST or SOAP service request? Yeah, that's what we've been talking about. And sometimes if you build it right, it is better. I think it is possible to make a connector better in every case. So 100% of the time, my opinion is a connector can be better. And I think Max's question kind of points to the fact that is it worth it to spend the effort to make one? And that isn't 100% of the time. So I did with Azure Storage, I did a thing where I just used the Microsoft Azure Storage API once because there was a one little thing that the MuleSoft connector didn't do, and I don't remember what it was because it was 4 years ago, for blobs, right? And we could have written our own connector, and it was just for this one little thing, so we just ended up calling the REST API in that case. So there are times that the effort to make the connector isn't justified. I can agree to that, but I always think that if you do make the connector, you're going to end up with a better final product than if you just use HTTP connector. So I didn't really do the connectors lesson. So in the class, in my proper class, we have a whole lesson on connectors and what they're made up of and all that stuff. But that's another side of Mule, right? Connectors are not, they're like a whole separate thing from flow programming. All right, this was probably the first study group I've ever done with a more theoretical Mule lesson. A lot of times we're very much more hands-on, practical, tangible stuff. So I don't know if you guys like this. If this is the kind of thing you want to do more study groups of, you should let us know. We'll be happy to kind of do more of these. Yeah.
Oh, I like it.
Yeah. Yeah. Well, good. We'll do some more of them. And if somebody has your own take on something to do with MuleSoft at all, anything to do with MuleSoft, I'd love to hear. You know what I'd really love to get at some point, if somebody wants to do it, I could do it, but I love to make the study group cooperative. If anybody wants to come on and talk about good and bad REST, oh my gosh, I would love to have that study group. So I could schedule one of these days, but yeah, if somebody's got a good and bad REST topic you want to present, I'd love to have it. So I think I'm gonna give you the screen back. RJ.
That was awesome, Ryan. I actually had something typed in the chat, just like people weren't asking questions just for a little bit, and I had it typed up, just kind of encouraging, hey, y'all drop some questions in here, and everybody just started rolling. I had to delete my comment. There was no need for it. That was awesome. Everybody contributed and was asking questions. I love it. I usually put this little thing at the end, and I don't think we need this today because everybody showed up asking questions during it, and that's what we want. So yeah, everybody pretty much said they like it, so it looks like we need to be doing this some more. I love the participation. So very cool. Ryan, you did a great job. I appreciate you coming here today. I appreciate your time. I appreciate everybody's time because I know everybody always has busy schedules. Just wanted to go ahead and put this out there for next week. Diane's going to be back. She's going to be doing part 2. I've got my flow built out. If you missed last week and you don't have your flow built out to where you participate in part 2, then jump over to that Integration Quest library that I shared with you on YouTube. Get on there. Everything that you need is already there. The links and everything. I've got everything that you need so that way you can build this out and you can join us for part 2 and come in and don't miss it. It's going to be a lot of fun. That's right. There's the little mule. It's going to be a lot of fun. Come join us and we'll be building this out. So again, thank you all so much. I'm going to stop the recording and everybody's welcome to hang out and chat like we all